video. In this video, I'm going to explain Adaboost mathematically. So if you've not watched my other previous video about Adaboost, I advise you to do so that you can understand this video. So Adaboost focuses on classification problems and aims to convert a set of weak classifiers into strong ones. So the equation for the classification can be represented as f of x. So f of x is equal to the summation from m is equals to 1 up to m. So theta m of x, and then f. So you find that this can be represented as in other research papers or in other literature, they can represent of each as hm of x. So here fm, so fm of x stands for the mth weak classifier. Is the mth weak classifier, and then here theta m of x represents the corresponding weight. So it's the corresponding weight. So let's say if we have a data set, so let's say if given a data set containing endpoints, let's say we have a data set with endpoints. So this is our data set with endpoints where xi is an element of, and then y so here -1 denotes the negative class, while 1 represents the positive class. So the first step is we initialize the weights. We initialize the weight for each data set. We initialize the weight for each data set as w x I y I is equals to 1 over n, where I ranges from I is equals to 1 up to n. So in this case, let's say we have 5 data points. So in this case, if we have 5 data points, then our weight for each data point is 1 over 5. So, and then the total sum of these weights should always add up to 1. So the total sum of these weights should always add up to 1. No matter what, they should always add up to 1. So now the next step is the next step is, let's say, for iterations from m is equals to 1 up to m, we fit weak classifiers to the dataset and select the one with the lowest weighted classification error. So the first stage is we fit weak classifiers. This is the weak classifier. So we fit weak classifiers and then we select the one with the lowest weighted error. And then the next stage is we need to calculate the weight for the mth weak classifier. That's the next stage. So to calculate the weight for the mth weak classifier, theta m is equals to half, that will be ln 1 minus the classification error over So this guys, if you relate to the previous key video, this E of M just represents the total air. So, so this is just the total air. If you relate from our previous video, this represents the total air. So let's say we had 5 data points, then our classifier makes 2 mistakes. So if we have 5 data points and then our classifier makes 2 mistakes, so the total error in this case, will be 2 over 5. Yeah. So that's the total error in this case. So for any classifier with accuracy higher than 50%, the weight is positive. So the more accurate the classifier, the larger the weight. And then the third stage is we update the weight for each data point as follows. So we update the weight. So this is the third stage. We update the weight for each data point as. So here, this is the previous weight. So multiply the previous weight. Then here is yi times the exponential of. So this is negative theta m yi fx fmx. This is I here. So and then we divide this by zm, where zm is a normalization factor. This is a normalization factor. So remember, I said that the sample weights should always add up to 1. So for them to add up to 1, we need to divide them by the normalization factor. So in this case, if a misclassified case is from a positive weighted classifier, the exponential term in the numerator would be always larger than 1. Thus, misclassified cases will be updated with larger weights after iteration. So the same logic applies to the negative classifier. So the only difference is that positive, positive, the only difference for negative classifier positive is that correctly classified samples will be updated with the larger weights. So it's just an inverse. So after the mth iteration, remember from our formula, we said that fx is equals to the summation from m is equals to 1 up to m theta m x and then fm x like this. So we are saying after the mth iteration, after the mth iteration, we can get the final prediction by summing up weighted prediction for each classifier. So we then sum up the weighted prediction for each classifier, and then we can then get our prediction. So thanks for watching, guys. I hope this video helped you a lot to reinforce your knowledge on Adaboost. So if you find this video, please subscribe and click the notification bell on so that you can continue to receive videos like this, which I will release every week. Thanks for watching.